Hello students, welcome to Educate. Today we are going to continue with rotational motion. So here we will study equations of rotational motion. As we have seen in case of linear motion, we write V equal to U plus AT. In a rotational motion, V will be replaced by omega, U will be replaced by omega 0, A will be replaced by alpha, and S will be replaced by theta. So let's see how the equations will look like. So V equal to U plus AT will be corresponding to omega equal to omega 0 plus alpha t. Second equation, S equal to ut plus half at square will be similar to theta equal to omega 0 t plus half alpha t square. Similarly, v square equal to u square plus 2as will look like omega square equal to omega 0 square plus 2 alpha theta. So these are basic equations and it is very easy to memorize them. You know, omega represents angular velocity. This is final angular velocity. This is initial angular velocity. Alpha is angular acceleration. Theta is angular displacement. If you want to know the origin, so I told you in the beginning that if you are given a circle and body moves in circular path, suppose this is radius r, this angle is theta, this is arc, then we write L upon r equal to theta, or we can write dl equal to r d theta, then we differentiate it, dl by dt is equal to r d theta by dt, and dl by dt is velocity r omega, and then further if we differentiate it, so dv upon dt gives r d omega by dt, and then it becomes a equal to r alpha. So these were the basic relations that we have already studied. Now here question says obtain omega equal to omega 0 plus alpha t using first principle. First principle means you are going to integrate. You are going to take the result of integration. So for that purpose, let's proceed. So you know alpha is given by d omega by dt, or you can write d omega equal to alpha dt. And now let's integrate it within limits. Here just write omega 0 to omega d omega equals time change 0 to t alpha dt. Now d omega will become omega, then you have limits omega 0 to omega, and this will become alpha t, limits 0 to t. Now this will become omega minus omega 0 equal to alpha t, or omega equals omega 0 plus alpha t. So this is how you have got first equation. Now here there is another question. It says the angular speed of a motor wheel is increased from 1200 revolution per minute to 3120 revolution per minute in 16 seconds. Assuming that acceleration is uniform, what is angular acceleration? That is to be found, and how many revolutions does the engine make during this time? So here initial angular velocity is given 1200 revolution per minute. We will convert it into revolution per second, and this is 3120 revolution per minute, and time is given. So we can apply formula omega equal to omega 0 plus L40, and then we can evaluate. So if you remember, angle moved in one revolution is equal to 2 pi. So here in our question, the information that is given is, in first case it is 1200 revolution per minute. It means you can write 1200 into 2 pi and divided by 60 to convert into revolution per second. So it will become in terms of radian per second. So we can get from here omega 0, this is omega 0. Similarly, in second case it is given 3120 revolution per minute, so we can convert it 3120 divided by 60, and one revolution means 2 pi radian. So we have got value of omega. Then we can apply formula omega equal to this formula omega equal to omega 0 plus alpha t, and we can get alpha. So omega 0 can be shifted in this side and then divide by time. So same thing is done here. So you can get this 4 pi radian per second square. Then we need theta. So theta equal to, you remember, theta equal to S equal to ut plus half at square formula. So theta equal to u is omega 0 t plus half alpha t square. And here we have got value of alpha as 4 pi radian per second square. Omega 0 is given here 45, and every information is given. So we can calculate it. So after calculation, we will get the value of theta as this 1152 pi radian per second. But in one revolution, here value of theta is given. So n times one revolution is 2 pi radian equal to theta. So our concern is to get n how many revolutions, theta upon 2 pi. Theta we have got as 1152 pi. So just to divide by 2 pi, we will get number of revolutions as 576. I think it is clear. Now, dynamics of rotational motion about a fixed axis. So in that case, there should be axis, and about which we can write its polar coordinates, and then we can evaluate. So how will we evaluate it? So work done, like earlier we have studied in case of linear motion, that f dot ds equal to, if we integrate f dot ds, we get work done, or in general way we write w equal to fs cos theta. In same way here, in terms of torque, we write force corresponds to, you remember, so work done will be equal to force corresponds to torque and s correspond to. So work done can be found by using formula torque into angle moved. And suppose we want to find out power, here we divide it by t, divide by t, we get f into v. Similarly here w upon t, if you write, so this will be power, and this will become d theta upon dt. If you write small value, or just write theta upon t, so this we can write power, and this is tau, and this is angular velocity. So this is another relation that is important one. So I think you have understood. Here the same thing, same comparison as I told you earlier is made, where we have seen earlier the displacement corresponds to angular displacement, velocity dx by dt is omega d theta by dt, Acceleration dv by dt is linear. Here alpha equal to d omega by dt. Mass corresponds to moment of inertia. Force F equal to ma. So torque corresponding to that, tau equal to I alpha. Then work dw equal to f ds. So w equal to tau d theta. Kinetic energy k equal to mv square divided by 2. Here m corresponds to I, is moment of inertia, I omega square by 2. Power p equal to fb, power p equal to tau omega. Linear momentum p equal to mv, so angular momentum will be L equal to I omega. So these are all concepts you know now. Now we are going to see the next thing. Here there is very good question. Question says, let's read the question first and then we will try to solve it. A cord of negligible mass is wound around the rim of a flywheel of mass 20 kg and a radius 20 centimeter. A steady pull of 25 Newton is applied on the cord as shown in the figure. The flywheel is mounted on a horizontal axle with frictionless bearings. Compare the angular acceleration of the wheel. Compute. Find the work done by the pull when 2 meters of the cord is unbound. Find also the kinetic energy of the wheel at this point. Assume that the wheel starts from rest. Then compare answer to part B and C. So let's see. With given information, mass is given, radius is given, force with which it is being pulled is given, and here pull when 2 meters of cord is unwound. So these are the conditions. So we can see the solution directly. So here, with given information, we know I alpha equal to tau. Why? So if you remember, F equal to ma. So here, if we write correspondence, so F corresponds to torque, m is I, and this alpha. So I alpha equal to tau and torque equal to force into perpendicular distance, so that is why tau equal to Fr. We put the values. Here R is given radius, that is 20 centimeter, and force acting is 25 Newton. So this will give torque, value of torque. Moment of inertia, this is a formula for moment of inertia about its axis, that is mr square by 2. So we put the value, m is 20 kg given, radius is 0.2, so square divided by 2. So this much will be the moment of inertia. And angular acceleration, so here angular acceleration we can find. So what formula? From here alpha will be tau divided by I. We put the values. We have got I, we have got here tau. So from there we can get this value, and then comes work done. So work done, force into displacement. In our question, force is given 25 Newton, displacement is 2 meter. So 50 joule work is done. Then comes next point. Next point is kinetic energy. We calculate. So here omega be the final angular velocity. The kinetic energy gain is 1 by 2 I omega square. So flywheel starts from rest. So omega 0 will be 0. So from this relation, omega square equal to omega 0 square plus 2 alpha theta. Angular displacement we can find, length of unbound string, radius. So here for getting this theta, we can do one thing. So what is length of unbound string, and then divided by radius of the wheel. So 10 radian is the value of theta. So from this equation, omega square we can find, omega 0 we have taken as 0. So 2 alpha we have already evaluated this much. So we put the values. So we get omega square equal to this. Our kinetic energy will be 50 joule. Here work done by the pull and winding 2 meter of cord is 50 joule. Here this is also 50 joule. In our question it was given that you have to compare B and C. So what you have observed, they are equal. So the answer are the same. The kinetic energy gained by the wheel equal to work done by the force. There is no loss of energy due to friction. So I think you have understood. Question is simple, but it is important. Now, other related concepts we have already studied, that torque is dl by dt, and in absence of torque L will remain. Suppose tau equal to 0, then L will be constant. So this is basic concept that is given here. Now there are different examples of conservation of angular momentum. Like suppose we have seen that in absence of torque, tau equal to dl by dt. So L equal to constant when tau equal to 0. So, but L equal to I omega. Now we will see different situations when L remains constant. In that case, we can generalize it. So I1 omega 1 equal to I2 omega 2. What does this mean? If moment of inertia decreases, then omega will increase. So there are different cases. Like here, there is one girl, and when she opens her arm, in that case, moment of inertia will increase. So her speed will decrease. If she is moving around here, and when her arms are closed, in that case, if her speed, angular speed, is suppose, take general example first. Suppose I1 equal to 4 kg meter square and omega 1 say 2 radian per second. And now suppose I2 becomes 6 kg meter per square, and we have to find out omega 2 in absence of any torque. Then what do? You will multiply these two. 4 into 2 must be equal to 6 into x. 4 into 2 must be equal to 6 into x. In that case, x means omega 2 will be different, but it will be less 8 by 6, that is 4 by 3 radian per second. So what you have observed, if omega is increasing, in that case I will decrease and vice versa. Here I is increased, so omega has decreased. So there are many applications that you can read. Now this was end of the chapter. Now we are going to see some more concepts. Suppose you go to the dimensions, etc. So let's see the dimensions of various quantities used here. So how to find? So you know, first quantity uses omega. Omega is d theta by dt, right? Here, if you want to write the dimension, so theta, angle is arc upon radius, and here dt is time. So this is length, this is length, this is time. So length will cancel out, time 1 upon time will be left, so t power minus 1. So that is what written here. Then angular momentum L equal to mvr. If we write the dimension of every quantity here, mass is m, velocity is lt minus 1, and this is L. So what do we get? ml square t power minus 1. So that is written here. Then comes torque. So what is torque? Torque is tau equal to either r cross f. So let's write the dimensions. This is L, this is m, L t power minus 2. So what do we get? m L square t power minus 2. Then comes moment of inertia, mi. Mi, as you know, it is mr square. So m, this is l square. So we have got the dimensions of various quantities involved in the chapter. Now we are going to see some numericals based on this chapter. So numericals are, here first question says give the location of center of mass of sphere. So in case of sphere, mass is uniformly distributed. So its center of mass will lie at the geometrical center. In case of cylinder, suppose you consider this cylinder, so its mass will lie on this axis. So center of mass will lie on the axis, geometrical axis you can say. In case of ring, mass is entirely concentrated on outer periphery. So its center of mass will lie here at the center. So you can say in this case, here there is no mass. So center of mass may or may not lie on the body. And next question is, if you are given a cube. So if you are given a cube here and you want to find out center of mass, then in that case, the line joining the opposite diagonals will intersect at one point and there center of mass lies. So this is first question. Now let's see second question. In HCl molecule, the separation between the nuclei of two atoms is about 1.27 angstrom. Find the approximate location of the CM of the molecule given that chlorine atom is about 35.5 times as massive as hydrogen atom. So we can evaluate it. Suppose here we write hydrogen atom, here we write chlorine atom, and its mass is 35.5, its mass is 1. Here this is origin. So let's say that CM lies over here. And the separation between them is given as, so this is suppose, this distance is given and this distance is x, so this will be 1.27 minus x angstrom. Now if you remember formula HCM, so what is formula? M1x1 plus M2x2 divided by M1 plus M2. So HCM will be equal to M1 is this 1, but x1 is 0. So plus M2, M2 is this much. So M2 you have to take as this 35.5 and x2. So here this whole distance is to be taken, although this distance I have noted as distance of the mass from center of mass. So here you will write just 1.27 angstrom divided by M1 plus M2, 1 plus 35.5. Now, if you evaluate it, what do you get? Try. You will get 1.25 angstrom, almost 1.235. It should be 1.235 angstrom. Just check the valuation. Then there is another question. Third question says, a child sits stationary at one end of a long trolley moving uniformly with a speed v on a horizontal floor. If the child gets up and runs about on the trolley in any manner, what is the speed of center of mass of the trolley plus child system? Here, if you remember, if there is no external force, then center of mass will move with the same velocity. So whatever velocity it has in the beginning, later on also it will remain same because external force or external torque is absent. So this is done. Now, next question says, show that the area of the triangle contained between the vectors A and B is 1/2 of the magnitude of A cross B. You have studied this concept earlier also. You know it very well. Suppose this is vector B and this is vector A. Right. So, here we can complete the parallelogram. So, this will be vector A and this is vector B. Right, this angle is theta. So draw perpendicular. This will be B sine theta. Area of parallelogram equal to base into perpendicular A into B sine theta, which is modulus of A cross B. And you know, here it contains two triangles. So if you divide it into two parts, so you will get first desired triangle that you want to find out. So area of triangle, half of area parallelogram, half of area of parallelogram. So you can say it will be 1/2 A cross B. So I think you have understood. Now, going to next question. Next question says, just read the question. Show that A dot B cross C is equal in magnitude to the volume of the parallelepiped formed on the three vectors A, B, C. So here you can make parallelepiped. So here suppose this is vector B, this is vector C. A dot B cross C is to be formed, and this is say vector A. So B cross C will be this portion, and we can find the direction of B cross C. If you remember, B cross C will be a vector perpendicular to both B and C. So this is direction of B cross C. Suppose this angle is theta. So we can find the area of this parallelepiped. So we need perpendicular distance, and that will be BC, this thing. So from here either we take the value perpendicular. So A cos theta, because theta is here, so this height will be A cos theta. So A cos theta will be height, and this is base. Right. Now to find, did you understand? Here angle is theta. If theta is like this, then it will be, in that case, A sin theta. But theta is here, so this perpendicular will be A cos theta. So now if we find A dot B cross C, so what do we get? We get A, then BC, modulus of BC, modulus of A, modulus of B cross C times cos theta. And you know this is base area. And This is base area. Sorry, we can write clearly. So BC is base area and A cos theta is height. So what do we get? We get volume of pylopite. So question says here A dot B cross C is equal in magnitude to the volume of the pylopite. So that we have got. Next question. Here find the components along the x, y, z axis of the angular momentum L of the particle whose position vector is r with the components x, y, z and linear momentum is p, px, py, etc. Show that if the particle moves only in x, y plane, the angular momentum has only a z component. So it is simple. What we write, if you remember, L equal to R cross P, right? And L can be written as Lxi cap plus Lyj cap plus Lzk cap, right? And R can be written as Xi cap plus Yj cap plus Zk cap. P can be written as Px I cap plus Py j cap plus Pz k cap, right? Now what you do? You need L. So L can be written as I j k, then R cross P. So X, Y, Z, then P, Px, Py, Pz. Now it is simple. Here you can evaluate. So if you write Lx, first you write just L, later on we will write the component. So here I times, if you take this, so Ypz minus, you are leaving this and this Zpy, then minus J, when you take this, so Xpz minus, you are taking this, so Xpz Zpx, and then write K cap. So when you take K, so Xpy minus Ypx. So here there is condition. If you write components, so Lx will be this much, Ypz minus Zpy. Ly if you write, so coefficient of J, so it will be Zpx minus Xpz because of this minus sign. And if you write Lz, so that will be this Xpy minus Ypx. Now there is one condition, that if particle moves only in xy plane, then angular momentum has only a z component. What does this mean? If it moves in xy plane, in that case z and pz will become 0. So wherever z and pz occurs, remove those terms. So this term and this term will vanish. What will be left? So here this is k cap times xpy minus ypx will be left. So this is because of k cap, you can easily say that this is only z component. So I think you have understood. So up to 6 we have done. Other questions we will consider in next lecture. Thank you. Team Educate.